Hello guys, today's lesson is on gas laws and kinetic theory. Today, we'll be able to learn and understand gas laws and the kinetic theory and different types of pressure and atmospheric pressure that it has on gases. Today we'll be able to recognize and know what the laws are and how to use them. Also, we'll learn what is kinetic energy and theory and what symbols and equations to remember and how to differentiate between the different types of laws. So first, in brief, we'll be talking about what is kinetic theory and what we should know about it. Later, we'll go in details. The kinetic theory describes a gas as a large number of submicroscopic particles, atoms, or molecules, all of which are in constant rapid motion that has randomness arising from their collisions with each other in the walls of the container, or in the air itself. Now, let's learn about what the kinetic molecular theory actually is. Let's talk about their characteristics and what's true about all the gases. So, the first rule is gases are made up of particles with no defined volume but defined mass. Volume is minuscule compared to the distance between volume. The next rule is number 2. Gas particles undergo no intermolecular attractions or repulsions. Particles possess no potential energy and their total energy is equal to their kinetic energies. Now we'll be talking about number 3. Gas particles are continuous and go in random motion. There's no knowing where they'll go. They go everywhere. Number 4. Collisions between gas particles are completely elastic. No loss or gain when particles collide. And lastly, number 5. Average kinetic energy is the same for all gases at a given temperature. Now we'll be talking about how gases are compressible, but they also can diffuse. Alright, so in this slide, we explain how gases are compatible and also diffuse. Gases consist of tiny molecules bouncing off each other because there's so much space in between them. It is easily compressible because when you compress the molecules together, the particles will run into each other more often because you're lessening the space between them. It is much easier to compress a gas because of the empty space there is, as opposed to liquid and solid, which are more packed together and has little to no space. Gas particles easily diffuse because the space around it makes the particles want to move and spread out. The molecules diffuse all over the places because they bounce around randomly in different directions. Now, we're also going to learn how gases can exert pressure and how it is accomplished. The molecules are constantly and continually colliding with each other with the walls of the container which they are in. When a molecule collides with the wall, they exert small force on the wall, and the pressure exerted by the gas is due to the sum of all these collision forces. The more particles that hit the walls, the higher the pressure. Just like the lower they hit the walls, it's lower pressure than if it would be hitting it more. Now that we talked about gas exert pressure, now let's talk about more in depth how it can be compressed. Now, no volume equals lots of space in between the molecules. The comparatively bigger space available between the molecules of gas and the atoms makes compression more simple and more easier. Gases can be compressed much easier than a liquid. We learned how pressure is exerted and how it is compressed. Now we should talk about what are the units of pressure. Standard pressure of ATM, kPa, and mmHg. ATM consists of 1. kPa consists of 101.325, and mmHg consists of 760. Standard pressure is referring to normal conditions in the atmosphere at sea level. Standard pressure is often used for measuring gas density and volume. Okay, now let's talk about volume of a gas, how it's measured, what are the units, what are the laws that go into it. Now, we obviously know that the variable for volume is a capital V and the units in liters is a capital L. Equally proportionate to pressure with T, which means temperature, as the constant, inversely less pressure equals more room, which is Boyle's law. Using a gas syringe, which withdraws a certain volume of gas from a closed system or chemical reaction. Alright, so now let's talk about how temperature is always expressed. The variable T is used for temperature, and units is in Kelvin, which is a capital K. We use the STP, standard temperature and pressure. Temp, O, Celsius, or 273 K. Constant, one volume and pressure are being changed. It's why it's proportional. This is the Boyle's law that's being used. And Charles' law is volume is directly proportional to temperature when P, which is pressure, is constant. We use this to express what temperature is. Alright, so now we're going to be talking about different equations and how to convert from Fahrenheit to Celsius and Celsius to Fahrenheit and so on to Kelvin, and how to use these equations to find the temperature you're desiring. So we see now here in the first slide on the practice problems that question on how to turn Fahrenheit, so we used Celsius degree and we plugged it into the equation and we came out to what the Fahrenheit is going to be. Now guys, let's try this for yourself. Alright, so now that we solved it, let's go over it together. So we see with 37 Celsius, we plugged it into the equation and we got 98.6. And for the second equation, we plugged in 10 Celsius and we got 50. And for the third one, 3 Celsius, we got 37. Alright, let's move to the next set of practice problems. Now we're going to convert from Fahrenheit to Celsius. Now the equation is Celsius equals 5/9 times Fahrenheit minus 32. We have 82 Fahrenheit, 70 Fahrenheit, and 32 Fahrenheit. Try to plug in everything in the equation and see what you get. Alright, now that we did it, let's go over the answers. So now that we have the equation, C equals 5/9 times F minus 32, we plug in the Fahrenheit into the equation. So when we plug 80 into the equation, we get 26.6 Celsius. Now with 70, we get 21 Celsius, and 32, we get 0. Because 0 is the starting point of a Celsius to Fahrenheit and Fahrenheit to Celsius. Alright, so now let's learn how to convert Celsius into Kelvin. The equation's pretty easy. What you do, you just plug in the Celsius and you add it to 273.15. Now, once you do that, you have your Kelvin. Let's try that. Alright, so now that we plugged it in, now we got 90 added to 273.15, 0 added to 237.15, and negative 15 added to 203.15. Once you add this, you have your Kelvin. Alright, now we're going to transfer Kelvin into Celsius. Now, the process and the equation to do this is almost the opposite on how to do Celsius into Kelvin. So what you have to do is you get the Kelvin and you subtract 273.15 and you have your Celsius. Just like if you plugged in the Celsius, you have to add 273.15. Now we have 100 degrees Kelvin, 350 degrees Kelvin, 200 degrees Kelvin. Let's plug it into the equation and see what we get. Alright, now that we did it together, let's see what our answers are. So, when we get 100 Kelvin subtracted by 273.15, that's our Celsius now. Just like 350 minus 273.15, that's our Kelvin. 200 Kelvin minus 273.15, you'll get your Celsius.